Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. It's our first video on using the nth term of a quadratic sequence. Let's start with something we already know, how to use the nth term of a linear sequence. So here's a question you should be able to answer. Here's a linear sequence. I want you to find the 20th term of that sequence. Pause the video and double check you can do that. Well, what you should have done is you should have worked out the nth term and then substitute the n is 20 in to find what the 20th term was. Now, the nth term of this sequence was 3n add 1. You found that it had a common difference of 3, and you wrote the 3 times tables above, and then afterwards you realized that our sequence is 1 more than that, so it's 3n add 1. Then you substituted n is equal to 20 into your formula for the nth term, and you got yourself that the 20th term would have been 61. So hopefully you understand that. The other thing we need to be super good at is actually substituting values into quadratic expressions. So I want you to do a bit of practice at that before we go forward in this particular skill. So in each of the following 3 cases, I'd like you to pause the video and I'd like you to find y when x is equal to 4 in the 3 cases. Well, hopefully you would have got the following answers. Y is 8, y is 32, y is 21. The key learning point I need you to be familiar with: when you're substituting into something like 2x squared and you're substituting in 4, you must do the 4 squared, which is 16, first and then double it to get 32. What students often make a mistake on, they do 2 multiplied by 4, which is 8, and then square that. Remember, if that was the way that we needed to work it out, we'd have written 2x with a bracket round it squared. But because we didn't, and we wrote 2x squared, that must mean you do the x squared first and afterwards you double it. So that's the key learning point from that. Let's get on to doing some actual questions about quadratic sequences and using the nth term. Here's an example. If you feel like you can do it, pause the video and have a go. Well, we're actually given the nth term of this quadratic sequence. We're told that the nth term Tn is 5n squared, and it says evaluate the first 4 terms. Nice and easy. We just make n be 1, work out T1, that's 5 multiplied by 1 squared. 1 squared is 1, multiplied by 5 is 5. So T1 is equal to 5. Then we're going to make n be 2, so we're going to get ourselves T2 is 5 multiplied by 2 squared. Remember, you must do the 2 squared first, that's 4, multiplied by 5 is 20. T2 is 20. Let's make n be 3. We've got ourselves T3 is 5 multiplied by 3 squared. 3 squared is 9, 5 multiplied by 9 is 45, so the third term is 45. And finally, we're going to work out the fourth term as requested, T4, that's 5 multiplied by 4 squared. Now remember, 4 squared is 16, and 5 multiplied by 16 is going to give us 80. So T4 is equal to 80. They are the first 4 terms. First term, second term, third term, fourth term, and we're done. Let's have a go at another one. Pause the video, have a go at this. Same old stuff, this time we've got to work out the first 3 terms. So let's make n equal 1, and we're going to work out T1. So T1 is equal to 2, 1 squared, add 3 multiplied by 1, take away 5. So 1 squared is 1, 2 multiplied by 1 is 2, 3 multiplied by 1 is 3, so 2 add 3, take away 5. 2 add 3 is 5, take away 5 is 0. The first term is therefore 0. Let's then make n be 2 and try and work out T2, i.e. the second term. So that's going to be 2, bracket 2 squared, add 3, bracket 2, take away 5. 2 squared is 4, times 2 is 8, 3 times 2 is 6, so 8 add 6, take away the 5. And that's going to give us the answer 9. So T2 is equal to 9. Let's finish off by letting n be 3. We're going to work out T3, which is going to equal 2, bracket 3 squared, add 3, bracket 3, take away 5. 3 squared is 9, 2 times 9 is 18, 3 times 3 is 9, so 18 add 9, take away 5. 18 add 9 is 27, take away 5, we get ourselves 22, and T3 is equal to 22. Here's our first term, our second term, our third term as requested, and we're done. Let's have a go at another one. Pause the video. This time we're asked to evaluate just the 5th term. So this time we're going to let n equal 5 and we're going to work out t5. That's going to be 10 subtract 2 brackets 5 squared. That's 10 subtract 5 squared is 25, 2 multiplied by 25 is 50, 10 subtract 50 is going to be negative 40. So t5 is equal to negative 40. And last one for us to try in this video. Pause the video, have a go at this. Don't use a calculator, whatever you do. So again, we're asked here to work out the 93rd term of this sequence. This looks difficult. So on the one hand, this is what you may do to start with. You may say, right, let n be 93. And we have to work out t93, which is clearly going to be 93 squared subtract 49. Now on the one hand, you could go off and work out 93 squared, which is 93 multiplied by 93, and then you could take away 49 from it. But there's a cleverer way. I wonder if you can see it. Well, remember, this is still 93 squared, but you could write 49. 49 is a square number. You could write it as 7 squared. Now does that look like anything familiar to you from the quadratic section? Well, it looks like the difference of two squares to me, which I know factorizes to 93 subtract 7 multiplied by 93 add 7. Remember, the difference of two squares, a subtract b squared, is a subtract b multiplied by a add b. Why does this help? Well, 93 subtract 7 is easy for us to work out, that's 86, and 93 add 7 is 100. And 86 multiplied by 100, well, that's super easy, that's 8,600. And who would have thought we would have got the answer to that so quickly and so easily? But we would have just by thinking of our difference of two squares. So it was a lovely link there to some work on quadratics. Anyway, that's it for this video. Thanks loads for watching.